everyone, and welcome to Science at Home. I'm Audrey Sherman. I'm a division scientist with 3M Company, and I work in the Medical Solutions Division. I've been with 3M for over 30 years, and a fun fact is that I am the first woman to hold over 100 patents in the history of the company. I'm currently sitting at more than 130 U.S. patents. So, let's get to the science experiment. So today, I'm going to talk about surface tension and adhesion and cohesion and how it relates to water droplets. I don't need gloves for this today because it's just water and an eyedropper. I do have my safety glasses on. I wear safety glasses even when I'm cooking bacon. Don't mess with your eyes, kids. You need them. So make sure you have something over your eyes when you're doing these experiments for certain. What we're using today is just a regular eyedropper, medicine eyedropper. I've got a glass full of water here today and a penny. And what's interesting about using a penny is pennies are a controlled surface. So they're the right size, they're all the same size, they're all the same diameter, even down to, I'm going to be using heads, not tails. Heads and tails are different, but every head is like every head, every tails is like every tail. So I'm using heads. And what we're going to do is take this eyedropper and count how many drops I can get to sit on this penny without going over. And I'm going to kind of give you 2 tips that I learned very useful for the science. I just, without going into the experiment, I counted how many drops my average eyedropper can hold. 20. So that way, if all of a sudden I'm not counting and I push the whole eyedropper on, you know what? It's probably 20. The other thing that I do is I'm going to steady my hand down on this marble because I want to make sure the drops go in the same place. So I'm going to make sure that I'm braced down here so that when I add a drop, it's going right where I want it to be. So those are my own personal tips. Kind of know about how much you're able to push out in a dropper. And then make sure you got a nice steady hand to do this because we don't want to push the drops off the penny. So if you're ready to get started, let's see how many Abe Lincoln can hold today for my eyedropper experiment. So we're going to count them, and you might be able to even see them come down. Got my hand on the ground here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. My eyedropper is empty. All right. Fill it up again here. That's looking pretty good. Again, I don't want to bump it. 21, 22, 23, 24, 25, 26. What was your guess? 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. There we go. 38. It was 38. It spilled over, so I would say that's 37. Now, the other thing that I like to do is we like replicates in science. So we're going to go through this really quick again. We had 37 before because 38 pulled me over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, oh, only 19 in that eyedropper. It's okay. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. This is incredible. Look at that dome. 31, 32. Oh, only 32 that time. There we go. So we've got a 37 and a 32. I'm drying these off with a paper towel. I'm going to do it one more time here because we're going to come up with the average of 3. Only this time I'm going to stop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Going to stop before we get there because I want to take a look at how nice this dome is. 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, I'm going to hold at 30 there. Boy, that is really forming just a beautiful shape. You can see now the water isn't flat on this penny. It's actually bulging up. And that's because the cohesive strength of that water. Water likes to stick to water. And so all the water down on the bottom is holding all the water up on top. And until that surface tension is going to break, and then it's just going to all flow out. And that's what we were watching before. So we'll see if we can get another drop in there. Yeah, look at that. It's really, really holding on now tightly. Even through the pressure of this drop hitting it, it's just going in there and staying. You can make the predictions, which is fun. You can do it 3 times, plot out what they are. But the other thing that's really cool is to try salt water. I would try sugar water. I would try orange juice. I would try milk. I would try warm water. I could try ice water. And what would be really interesting is with all that data, I could start to form a nice plot and probably be able to infer some things about milk and possibly salt water versus orange juice and maybe cold water. I haven't done these experiments yet. They're for you to do and come up with explanations as to what's going on. So I want to thank you guys for taking the time with me. And I'm Audrey Sherman. And I hope you check back for Science at Home videos from 3M. Because really, science is simple, science is fun, and everyone can do it. So thank you guys.